I'm happy really to be with you. I work with the BBC World Service, and today I'm going to speak briefly about the issues of rendering Arabic script on DAB radio. And we are familiar really with left to right languages, and obviously we have so many solutions available for them. But then there are scripts that are also read right to left, and such as Arabic, Hebrew, Persian, and Urdu. So we really realize that we need to be able to deal with the situation. And the fact is that it's not that there are no Unicode systems to render this text. In fact, there are actually more than one. So the first question we had to deal with was, do we expect receivers to deal with all of them at the same time? Obviously, with high-end receivers, it might be possible to do that. But then in some developing markets, low-end receivers are not necessarily able to do that. So to go back to the issue of the Arabic script itself, one of the things is some of you might know is that the Arabic alphabet has so many consonants, and when it's written, they are rendered differently depending on the position of the letter in the word. So I don't know if you can see the table. So at the start, the letter is rendered in one shape, and then it changes in the middle, and it changes in the end. And there's also the isolated form itself. So this was the main challenge that was faced by using technology in the Middle East since a very long time. And we're going to look now at some early examples of Arabic display. And these are basically, we can see here one high-end device on the left-hand side, and then on the right-hand side, a low-end device. And the high-end device, as expected, renders the Arabic script very well, very clear, including all the punctuation marks. But then on the other side, we can see that, first of all, the device didn't render the whole sentence. And on top of that, it missed some of the punctuation marks. So this is one part of the problem that we're talking about when we say that we needed something that works in all devices at the same time. Another example here, which is very interesting, it's an Arabic sentence that has some words in English. And the question here is how the devices are going to deal with it. Is it right to left or left to right? Now, high-end devices have enough processing power to actually realize that what is right to left and what is left to right. And as we can see here, it's rendered perfectly on the high-end device. However, on the other side, the device got confused. So it treated the whole text as right to left and rendered the Arabic letter in their isolated forms. So for legibility, this is a nightmare. And if you look at the English word here, the tiny one, which looks like DNA, this is actually the last bit of the word understand. And as you can tell, the low-end device rendered even the English text right to left. So eventually, it boiled down to choosing between two Unicode systems. And as I'm going to show you now, we have two examples here. These two Arabic sentences, they look the same, but they are coded differently. And the first system is called the Arabic number sign. And this is a Unicode system which is basically it uses one code point per letter, regardless of its position in the word. So obviously, the receiver or the device here has enough processing power to figure out is the letter at the beginning of the word, is it in the middle or at the end, and depending on that, it will render it. It will render its shape correctly. So if you look at the Unicode text here, the red ones, they are all the same code points, but they correspond to letters that are written differently in the Arabic sentence above. So eventually, with the Arabic number signs, for this sentence, we have 3 code points only, and it actually reflects the number of letters in this sentence. There are only 3. However, there are 11 glyphs that are required, which again correspond to the shapes. So the other system is called the Arabic Presentation Forms B. And if you inquire now about what is Arabic Presentation Forms A, actually, Presentation Forms A is used for other languages that are right to left, such as Persian and Urdu. And it's because these languages have even more consonants than Arabic, and which are rendered differently. But anyway, back to Arabic now. Here in this system, we have, again, the same sentence, but for each code point is different from the other one. So that we have one letter, and it has at least 3 code points. And each code point represents a specific part of a specific shape of the letter itself, and then renders it accordingly. Now, if you compare the Arabic number sign with the Arabic presentation forms, in terms of memory, actually they're not they're not really much different because, after all, both of them rendered 11 glyphs. However, in terms of processing, this is where the challenge comes because the Arabic number sign actually requires more processing power. And this is, for example, the way the Arabic script is rendered on computer laptops. Obviously, computers have efficient processors that can run through the permutation of Arabic letter shapes and then render them accordingly. However, this one is more basic. In terms of memory, it does the same thing, and I would say it's more reliable. So the question is, which one are we going to use? Are we going to use example 1, the Arabic number signs, or example 2, Arabic presentation forms? So the European Technical Standards Institute advises that by default, devices had to use the Arabic presentation forms, the more basic one. And the reasoning here is that in terms of storage space, actually, both of them work efficiently on low-end devices and high-end devices. And as I showed, for both examples, we need 11 glyphs. So in terms of memory, there's no problem. However, in terms of processing power, which is the key here for low-end devices, example 2, the Arabic presentation forms B, need less processing power and less memory for that. So essentially what this does is that it really takes the worry from the broadcasters about whether or not their Arabic scripts are rendered correctly. And also it provides simplicity, eligibility for low-end products. And for this, the ETSI also recommends that if high-end want to use more sophisticated Unicode systems, they can. However, they need to use the basic one as a foundation, and then use the more sophisticated one. And if the receiver has a problem, then at least it has a system that works, which it can basically go back to.